a land of rivers and dreams, faces a paradox. While some regions are drowning under relentless floods, others are parched, struggling for every drop of water. Imagine a nation where water flows where it is most needed, from river to river, state to state. This is the vision of river linking, a monumental idea aimed at balancing nature, empowering communities, and uniting the country through water. Long before the age of megadams, India mastered the quiet art of water management. Across the subcontinent stood stepwells in Gujarat and Rajasthan, tanks in Tamil Nadu, and canals in the Gangetic Plains. Intricate systems built not by machines, but by community hands and shared wisdom. For centuries, these systems sustained civilizations, communities, and livelihoods. Among the earliest pioneers was the Kalani, or Grand Anacut, built across the Kaveri nearly 2,000 years ago. Even today, it diverts river water flawlessly, a living monument to timeless engineering. Medieval kings and local chieftains expanded these ideas, constructing bunds, reservoirs, and canal networks that turn arid plains fertile. As India entered the modern era, visionaries and engineers sought to carry that legacy forward. The dream was no longer limited to villages or kingdoms, but to connect entire rivers across states, ensuring water reached every corner of the nation. In the decades after independence, leaders like Sardar Vallabhbhai Patel and hydraulic pioneers such as Dr. Khosla championed a national water strategy. Their vision sowed the seeds for projects like the Sardar Sarovar Dam and later the National River Linking. From the stillness of ancient stepwells to the roar of modern spillways, the story remains the same. A country forever learning to balance abundance and scarcity, tradition and technology, past and promise. After independence, India's water vision took on a national character. Recurrent floods in the Ganga Basin and droughts in the Deccan Plateau demanded a single unifying solution. Could the abundance of one region heal the scarcity of another? In the early 1970s, Dr. K.L. Rao, a visionary engineer and former irrigation minister, proposed the National Water Grid, a vast network connecting major rivers through canals and reservoirs. Though considered ambitious for its time, the idea ignited a conversation that never truly faded. In the decades that followed, India refined its approach, developing the concept of inter-basin water transfer. Water would move from surplus to deficit basins, ensuring equitable distribution across states and seasons. Yet the true challenge wasn't only about building canals, it was about maintaining flow integrity. A single miscalculation in gradient could stagnate water or erode entire sections of the channel. This is where systematic desilting became essential. Rivers naturally carry fine sediments that settle when velocity drops. Over time, these deposits distort the channel's gradient, creating uneven flow and even reversing direction in extreme cases. To counter this, engineers devised desilting basins, slope correction structures, and cross regulators, all designed to maintain a homogeneous gradient and consistent hydraulic head. In essence, the science of linking rivers is as much about managing the motion of silt as it is about moving water itself. The first tangible results began with pilot links, notably the Ken-Betwa project, followed by studies on the Godavari Krishna and Partapi Narmada links. These projects tested the theories of flow balance, sediment control, and ecological impact, turning decades of vision into practical, measurable design. The dream of a connected water network was no longer an abstract concept. It was becoming a coordinated engineering reality. And at the heart of this progress lies one timeless principle: balance. The balance between rivers, between regions, and between nature and human ingenuity. Today, the dream once drawn on paper has evolved into a national engineering roadmap. The National River Linking Project, or NRLP, conceived under the National Water Development Agency, the NRLP envisions 30 major river links across India, connecting 37 rivers through nearly 15,000 kilometers of canals, reservoirs, and pumping stations. The plan is divided into two key components: the Himalayan link and the Peninsular link. The Himalayan component aims to transfer floodwaters from northern rivers like the Ganga and Brahmaputra toward the drought-prone basins of Rajasthan and Gujarat. Meanwhile, the peninsular component connects the southern rivers, Mahanadi to Godavari, Krishna to Kaveri, and onward to Vaigai and Gundar, ensuring a continuous, balanced southward flow. The objective remains simple: to stabilize the nation's water distribution by linking abundance with need. Modern technology now guides every stage: GIS mapping, hydrological modeling, remote sensing, and AI-based flow prediction systems ensure that every drop is tracked, measured, and optimized. But large-scale water transfer requires precision at every level, from gradient alignment to real-time sediment load monitoring. Today's interlink designs incorporate automatic desilting gates, energy-efficient lift systems, and adaptive flow regulators that respond to rainfall and reservoir pressure in real time. What was once a paper vision has matured into a digitally monitored, climate-adaptive water grid. The benefits extend far beyond irrigation. The NRLP is projected to generate 34,000 megawatts of hydropower, create tens of millions of hectares of irrigated land, and secure drinking water for hundreds of towns and cities. Yet it is also a project of balance, a balance between technology and ecology, between regional aspirations and national vision. Each canal, each reservoir, each flow regulation system, together they form a living blueprint of a nation engineering its water future. Every great engineering dream faces its test in reality. For India's river linking vision, that test lies in the complex intersection of ecology, economy, and equity. Critics warn that altering natural river courses can disturb ecosystems built over thousands of years. A change in flow pattern can reshape floodplains, affect fish migration, and threaten biodiversity in wetlands and delta regions. Downstream communities fear reduced sediment deposits that sustain agriculture, while upstream regions worry about loss of forest catchments to reservoirs and canals. Another challenge is rehabilitation and resettlement. Each link demands vast tracts of land for canals and storage. land often inhabited by rural and tribal populations. Ensuring fair compensation, livelihood restoration, and cultural preservation remains an ongoing struggle. Then comes the interstate dimension. Rivers, by their nature, do not recognize political boundaries. Balancing water rights between states and between riparian nations requires delicate negotiation, legal clarity, and trust. The Supreme Court and river tribunals have, over decades, issued numerous verdicts to harmonize competing claims. Yet disputes continue to surface whenever rainfall, demand, or politics shift. Environmentalists also question the energy footprint of large-scale water transfer. Lifting water over long distances consumes immense power, and climate-driven variability in rainfall could alter cost-benefit equations. But engineers counter that innovation, from gravity-based canal design to solar-assisted pumping and AI-driven water balancing, can minimize both environmental and financial costs. Between the optimism of progress and the caution of preservation lies the true challenge: how to connect rivers without disconnecting people or nature. The future of India's water security lies not only in construction, but in coordination, data, and governance. The National River Linking Project is now entering a new phase, one guided by science-based planning, digital monitoring, and interagency collaboration. The integration of GIS mapping, IoT-based flow sensors, and hydrological AI models allows engineers to track real-time changes in discharge, silt load, and rainfall patterns. This data-centric approach is transforming river interlinking from a static design to a dynamic management system, one that adapts to climate variability and seasonal monsoon shifts. Under the National Water Informatics Center, river data from across India is now being digitized into a unified basin-level database, enabling predictive control and early warning during extreme events. Technically, future river links will depend on low head lift designs, gravity-optimized slopes, and sustainable desilting technologies that reduce both cost and energy consumption. Currently, Ken Betwa is the first project under active implementation, while other priority links, Godavari Krishna, Partapi Narmada, and Mahanadi Godavari, are under detailed feasibility and clearance stages. At the policy level, the emphasis is shifting from physical expansion to integrated basin management, promoting river health, groundwater recharge, and equitable sharing through coordinated planning. The long-term success of the project depends on nurturing a new generation of hydrologists, ecologists, and engineers who understand both the science of water and the ethics of its use. India's river linking vision is not merely a project, it is a continuing policy evolution, balancing technology with ecology and national growth with local sustainability. As the country engineers its water future, one principle remains constant. Every drop must serve life, purpose, and balance. As India moves toward a future of engineered sustainability, the interlinking of rivers stands as more than a project. It is a vision of equilibrium between nature and human design. Each canal, dam, and control gate represents a step toward precision water management, a challenge that unites civil, mechanical, and environmental engineering under one purpose: From ancient tanks to automated systems, our legacy flows forward. Through innovation, resilience, and the enduring spirit of engineering the nation's water future. This is Flowline Chronicles, where every drop tells a story.